Here's a quick solution to quiz 9 practice. Okay, with vectors, you've got this vector and that vector. 2u is the vector 0.6, comma, negative 1.4, minus 1, negative 0.8. Should come out to 0.6 minus 1 is negative 0.4, comma, minus a negative means adding that, so that's minus 0.6. U dot W, 0.3, negative 0.7, dot product with 1, negative 0.8. You multiply the x-coordinates, 0.3 times 1, plus negative 0.7, the product of the y-coordinates, negative 0.8. That's 0.3 plus 0.56, which is 0.86, only a single number, not a vector. The magnitude of u is the square root of 0.3 squared plus negative 0.7 squared, which is going to be square root of 0.09 plus 0.49. So the square root of 0.58. For the angle between u and v, you need u and w over the magnitude of u, magnitude of w equals cosine theta. Now I already have the dot product, I already have the u, so maybe I ought to do w here. Magnitude of w equals the square root of 1 squared plus negative 0.8 squared. Let's see, that is 1.64. So this right here is 0.86 over the square root, that's the dot product, over the square root of 0.58 times the square root of 1.64. That's equal to cosine theta. So theta equals cosine inverse of 0.86 over square root of 0.58 square root of 1.64. Okay, so let's see if I can't get that into a calculator for us. If I'm on in degrees and I take cosine inverse of 0.86 divided by the quantity square root of 0.58, close the square root, times square root the quantity 1.64, close that, close the parenthesis, close the cosine inverse, and I get 28.142 degrees about. On the second problem, what I'm working on is I'm working on putting these two together. So let's see, I have 2 times z. 2z is 2 minus 2 root 3i. W is root 3 plus 3i. So multiplying those two things, I'm going to get a 2 root 3, a 6i, a minus 2 root 3 times root 3. Root 3 times root 3 is 3, so I have a minus 6i, and then a minus 6 root 3i squared. Now remember, I squared changes that to be a positive because I squared is negative 1. So I have 2 root 3 plus 6 root 3, which is 8 root 3. And these cancel, so that's all I have there. Now here I have root 3 plus 3i over 1 minus root 3i, which is 1 plus root 3i, 1 plus root 3i. The denominator is going to be 1 squared, cross terms cancel because of the conjugate, minus 3 I squared, which is going to make that 3. Then I have a root 3 here. That's this. Oops, the first one. The second one is 3i. The third term is 3i. And the fourth term is plus 3 root 3 I squared. And of course, the squared I squared cancels, and that becomes a minus. So what's that come out to? It comes out to root 3 minus 2 root 3, which is negative 2 root 3 minus 3 root 3, which is minus 2 root 3 plus 6i all over 4, which can actually be simplified to negative root 3 over 2 plus 3/2 I. Okay, 2 more to go. What is the conjugate of z? Well, the conjugate of z is 1 plus root 3i. W is root 3 plus 3i. So, again, distributing everything, I get a root 3. I get a 3i. I get another 3i. I get a plus 3 root 3i squared. I squared makes that negative. So I have root 3 minus 3, which becomes minus 2 root 3 plus 6i. That's what's there. Here, what I'm going to do is I'm going to write this as z squared squared. So first, let's figure out what z squared is. That's 1 minus root 3i, 1 minus root 3i. Then I'm going to square that. Okay, that's going to be my strategy. So what do I have on the inside? I have a 1 minus, now notice you have a root 3i, another minus root 3i, a plus 3i squared, all squared. So what's that actually going to be? Well, that's actually going to be a 1 minus 3. So that's minus 2. And here, minus 2 root 3i, all squared. Let's come back and work on that one. This times itself, 4 minus 4 root 3i minus 4 root 3i plus 4 times root 3, which is 3. So that's 12i squared. Okay, we're almost there. I squared becomes a negative. 4 minus 12 is minus 8. And here I have minus 8 root 3i. There you have it.